So if we're looking at Earth, we'd probably want to talk about, the types of ships that we'd use in low Earth orbit first, right?
Exactly, which for that I can see two primary types, which is going to be the ships that actually get you off of Earth and into low Earth's orbit, and then the types of ships you're actually going to see moving around low Earth's orbit. And those have very different design considerations, obviously. It doesn't really make sense to only move around habitats with ships that are also designed to go into atmosphere, because you need to carry a lot of extra weight and have a lot of extra components to be able to operate in an atmosphere and in a vacuum.
Of course.
So once you're actually in orbit, you're probably going to have much smaller, lighter ships that just move from habitat to habitat and that are not actually capable of re-entering Earth's atmosphere.
Yeah, because they wouldn't need the thrusters capable of getting them out of Earth's orbit to begin with. Just enough thrust to get them around in a zero gravity environment.
Yeah, exactly. And we typically imagine low Earth's orbit being a fairly busy place in the future. Lots of different manufacturing sites, O'Neill cylinders, places where people live. And it really doesn't take a lot of energy to move from very similar orbits, right? Like if you have two O'Neill cylinders that are both in a low Earth's orbit, then the delta V required, or the actual change in velocity required to move from one to the other, isn't a lot. Right. In fact, you could do it in a fully ballistic trajectory, and very well you might have a system where you have little shuttles that are basically accelerated out from one station to almost perfectly match the orbit of the next one, with maybe some small thrusters for redundancy and to fine-tune the orbit.
That's actually a really cool concept. It would act more as like a catapult or a slingshot, with just being able to make slight adjustments as you need them to be able to go from one station to the next. But you got to go and view your parents. You're going to be traveling back and forth from these space stations all the time.
Yeah, you can actually move between these stations a lot. This very well could be a normal commute you do. You might work in one station, live in another. One station might not really have a lot of human habitation. It could be just farming, and you need to commute there every day. So you might have a system on your space station that launches you out and gets you to that other station, and that station has a system that catches you. And the actual spaceship itself doesn't really need to be anything more than a pod with some basic thrusters, and it doesn't even actually need to have thrusters to slow down or speed up much. You might have them for redundancy, but your acceleration and deceleration could fully be done by launching you out of one station and then catching you in the other. And it might even work that the fee you pay to move from station to station is dependent on the delta V they expend to accelerate and decelerate you. So like your station might charge a small fee because when they launch you, that slows them down and they have to adjust their orbit. But the receiving station might actually give you a credit, because when you reach them, they pick up some speed from decelerating you, and that helps boost their orbit.
It's actually such a cool concept, because you, of course, need to maintain that thrust, just like how our International Space Station does now. So, every time that you project mass, you lose a little bit of that thrust, and every time that you gain mass, you gain a little bit of that thrust. It's just such a interesting idea.
And it could also be very well that you see dynamic pricing, right? Everyone loves good dynamic pricing, but you might find it at certain periods of time cheaper to leave your station when they already need to do a control burn to slow down their orbit or speed up in their orbit. They might offer a discount on destinations that already align with that, and that means they have to expend less mass when it does come time for them to do that. It's likely this could be only a few minute commute from station to station if they keep similar orbits. So for near transit, it really might just be a small life support system for redundancy, a couple of small thrusters in case they need to make maneuvering changes in their orbits. And we compare and contrast that with a ship that needs to be able to transit from Earth's surface to orbit. The complexity goes up an order of magnitude if you've got to be able to re-enter and exit the atmosphere. I mean, re-entry alone is a very energy-intensive process. Not only do you need to be able to do a deceleration burn to enter the atmosphere, you need to be able to handle the heat of re-entry. If we're not assuming we have any special thing to catch you in orbit, and you actually need to be able to come all the way down and land on Earth's surface itself, then you need some type of heat shield, whether that's an ablative heat shield, which I would hope that we get away from ablative heat shields at this point and maybe have a more reusable heat shield, something that's actually cooled with something like a cooling loop, so you're not constantly losing material and having to rebuild the heat shield every time you land, because that's a very expensive thing to do every time your ship lands.
Yeah.
But even if you do an ablative heat shield, that's very possible. But I do think that maybe these ships, we could see more like space planes. That would be very nice, that are actually able to take off and land. That's the dream. That's what the shuttle was supposed to mimic. So hopefully that's something we see.